the formula for the surface area can be calculated this way. The area of the surface f of x, y, z equal to c over a closed and bounded plane region like R is given by, so the surface area is the double integral of the absolute value of the gradient of f, or the magnitude of the gradient of f, divided by the magnitude of the dot product between gradient of f and p dA. P is a unit vector which is normal to region R, and please note that the gradient of f dot p is never 0. So we're going to apply this formula for the following example. Find the area of surface cut from the bottom of the paraboloid x squared plus y squared minus c equal to 0 by the plane z equals to 4. What is the area of that surface? At any point like x, y, z on the surface, we have f of x, y, and z, which is x squared plus y squared minus c. This is our function in 3 free variables. The gradient of f is 2xi plus 2yj minus 1k. Now, the magnitude of the gradient of f is the square root of 2x squared plus 2y squared plus negative 1 to the second power, which can be written as the square root of 4x squared plus 4y squared plus 1. If we calculate the norm of the gradient of f dot p, this in turn is equal to the magnitude of the gradient of f dot k. K is the standard vector along z-axis, 0, 0, and 1. In turns is equal to, well, here if you do the multiplication, the dot product, 0 times 2x is 0, plus 0 times 2y is equal to 0, and then 1 times negative 1 is negative 1. So you're basically just calculating the magnitude of negative 1, which is basically 1. Following the surface area formula, you have the double integral of the magnitude of the gradient of f divided by the magnitude of the dot product between gradient of f and p dA, which in turn is equal to whatever you calculated here, divided by 1 dA can be written as dx dy over the disk x squared plus y squared less than equals to 4. Again, if we look at the projection of this object in xy plane, this is basically a disk. Well, from polar coordinates, we know that if x is r cosine theta, y is r sine theta, dx dy becomes r dr d theta. Our r ranges between 0 and 2, and theta has a full rotation 0 to 2 pi. This in turn is equal to the integral 0 to 2 pi of 1 over 12 for r squared plus 1 to power 3 halves, while r ranges between 0 to 2. And then if you do the calculation, you get pi over 6 times 17 square root of 17 minus 1. Again, if you want to have an approximation, numerical approximation, it's better to use a calculator.